Hi everyone, welcome back. So this is our last section in chapter 7. I think we only have 4 more sections left in chapter 8. So you guys are almost done. Woohoo! So this section will be presented again in Math 51 on steroids because they do it with polynomials and then they do it with rational equations. So it's a scary section. So if you can at least get this part of it, then when you learn the rational expressions in the next class, I think it'll be a lot easier, hopefully. I did put 2 of these on the test, so you will see this. So you do want to make sure you do your homework because there's not that many on the test, less than 20 for sure. So 2 of them are from this section. So these are going to be quadratic and polynomial, but now instead of equations, they're going to be inequalities. So quadratic, remember, is second degree. Polynomial could be second degree, third degree, fourth degree, fifth degree, and so on. We're only going to deal with second and third, but in the next class, like I said, you'll have a lot higher powers, plus you'll have the fractional equations. So if you can get this part, at least familiar, then it will make this section easier next semester. So from 7.4, we learned that this is a parabola, and we learned that if A is positive, it opens up. If A is negative, it opens down. So when we have this with the same quadratic function saying greater than 0, we're asking when is the function positive? Because isn't that what greater than 0 means, positive? And in reality, positive means when is it above the x-axis? And we're also going to work with having a quadratic less than 0. Well, anything less than 0 is negative, but on a graph, that means where is the graph below the x-axis? So just think of greater than meaning above x-axis, and less than meaning below the x-axis. Those are probably the 2 most important things of the whole section. Once you get a grip on those, it's not very hard to understand this section, but a lot of students struggle with inequalities and don't really understand what they mean. So greater than 0 is positive. Positive numbers are above the x-axis. Less than 0 are the negative numbers. The negative numbers are below the x-axis because we're talking about y's, because notice that the greater than less than 0 took the place of y. So use the graph of f of x equals x squared plus 5x plus 4. So here's the graph they made up for us. Let's go ahead and put our arrows on it to solve. Okay, so this first one wants to know when is the graph above the x-axis? And we do use interval notation for these. So back when we did inequalities and when we do domain and range, we use interval notation. These do too. So I'm going to do above in red and I'm going to do below in blue, just so you can see it on the graph. Okay, so greater than is above, less than is below. So let's look at the part of the parabola that's above and below. So this is above the x-axis, and this is above the x-axis. And there's no equal sign, so generally when there's not an equal sign at the x-axis, we put open circles. And the part below the x-axis is right there. Okay, so that's the first part, is we have to know what part of the graph is above, what part is below, and then circle the x-intercepts. If there's an equal sign, then we make the x-intercepts solid. but when there's no equal sign, if you remember from inequalities from your previous classes, then it's open. So the parabola is above the x-axis for anything less than 4. Less than -4. So that would be, let's do it with this pin. That would be all these x values. Does everybody agree? Because this x is going to go with that, this x is going to go with that, this x is going to go with that. So all these x's are when the graph is above the x-axis. So how do I name all those x's? Well, this is where you have to summon your knowledge from inequalities. You go from smallest to largest, left to right. So from -infinity to, and this is -4. And because there's no equal sign, it gets a parenthesis as well. So -infinity to -4 is when this left side of the graph is above the x-axis, because we always name it with the x values. But then it's also above the x-axis here. So that would go with all these x values, because this is that, this goes with that, and so on. So how do I name that? Well, this is -1, and it is an open circle, so it gets a parenthesis, and then it goes on to infinity. So because we have two intervals, remember in chapter 6 how we learned to put the u in between? So we would say the graph is above the x-axis from -infinity to -4, those x values united with -1 to infinity. So those are the two times for all those x values when the graph is above the x-axis. When the graph is below the x-axis, now let's switch to blue. It is from -4 to -1, so it's these x values. So from -4 to -1 on the x-axis, that's when the graph is below the x-axis. So we would write it like this: -4, -1, both with parentheses. So that's when it is below the x-axis. So just for practice, let's try one. And like I said, this will get easier the more you practice, but it's not something you're just going to be good at automatically. So you definitely need to make sure that you practice this section, because this is probably the least familiar of everything we do in this section, I think. Probably something you've seen the least of. Okay, so they have already graphed this parabola for us. If you want to verify factors of 15, that subtract to 2 would be 5 and 3, and the largest one's plus. So this would be x plus 5, x minus 3, and if we set those equal to 0, our x-intercepts would be x plus 5 equals 0, x equals -5. So the first x-intercept would be -5, 0, and you can see they have that plotted right there. And it should be an open circle. Get my black out. I accidentally started making a point there. And then if you take the second one and set it equal to 0, x minus 3 equals 0, you get x equals 3 when you add 3 to both sides. So that makes that x-intercept 3, 0. And we know the parabola cups up because the leading coefficient's positive. So some of them you're going to have to graph. Some of them they will already graph on our test. You have to graph them yourself. So that's why I went over that step. Okay, so the parabola's ready. All we need to know is that it cups up and where it crosses the x-axis. We don't have to do the vertex and all that fancy stuff. We just need to know the general form. So cups up, 2 x-intercepts. We made the x-intercepts open circles because there's no equal sign. So first, we're going to tackle the x squared plus 2x minus 15 is greater than 0. So we want to know, when is it above the x-axis. So we're going to stay with our colors from the last. So above the x-axis would be this part of the graph and this part of the graph, right? So now we have to figure out what x's go with that. Well, this is going left forever, so this would correspond to these x's. And this one's going right forever, so this would correspond to those x's. So because there's two intervals, we know our answer is going to have a u in it. And let's name this first one. Remember, when we're doing x values, we have to go smallest to largest. So the smallest x is negative infinity. And we won't have any brackets because there's no equal sign here. The largest x in this interval is negative 5. And then we're going to unite it with these x's because this is the other spot where this graph is above the x-axis. And this is 3 with a parenthesis because there's no equal sign to infinity. So these are the x values that correspond to when the graph is above the x-axis. And it's a totally different scenario when the parabola is upside down. We'll do one of those later. But you have to draw it every time so you can picture it, get these in the correct order, and name your solutions. So these are all the x values for when the graph will be above. But then they also want to know, when will the graph be below? So let's go over here. X squared plus 2x minus 15 is less than 0. This means, when is the graph below the x-axis? And that would be here up to here. So that would correspond to these x values. And this is negative 5. This is 3. No equal sign, so we'd write negative 5, comma 3. So every x value between negative 5 and 3 will be assigned to a y value below the x-axis. So this is not the point negative 5, 3. This is all x values from negative 5 up to 3 have y values that are below the x-axis. Fun, huh? And this is a fun section. Once you get used to it, you'll be like, oh, I like this. This is fun stuff. Okay, we have 2 minutes. I think we have time to start on a problem on the next page, or at least talk about the box up here. So, definition of boundary points. So the boundary points are our solutions. Just like on the last problem, our boundary points would have been negative 5, 0 and 3, 0, because there are two x-intercepts, right? So x equals negative 5, x equals 3 would be the values on the x-axis. These would be the actual points. So they're called boundary points. They're the solutions or the x-intercepts. Okay, so solving the inequality by using the test point method. So this is what they're going to show you in 150. We're going to do a couple with this. Mostly we're going to be drawing parabolas today, but we will do a couple with this. So first we find the boundary points. So this would be the solutions. And then we plot the points on a number line. So we don't have to draw a graph. We can just do a number line like they did down here. See how they have solutions here? And next, this is going to divide the number line into intervals. And I'm going to just make this smaller so I don't have to keep going up and down. So you can see we have left of this point, in between these 2 points, in between those 2 points, and right at that point. So those are called the intervals of the number line, because this is the boundary, this is a boundary point.